Hello students, myself SD Sir from EDUINFINITE Kolkata. Today I will discuss something about the reaction mechanism, which is a very important part of organic chemistry. Those who are in class 11, we concentrate onto this part from your textbook, and otherwise very difficult to follow the reactions in class 12 portion, which covers around 30% of question from organic chemistry class 12. Now, what is reaction mechanism? The path by which a reactant is converted into product. That path is called reaction mechanism, and the various species formed during the course of the reaction are called reaction intermediates. We know there are different intermediates: free radical, carbonium ion or carbocation, carbanion, then nitrine, carbene, benzene, etc. Of all these, we have free radical, carbocation and carbanion mechanism. Now the question is how the carbocations are being formed. There are so many ways. First one is when carbon is attached with a more electronegative group or atom, then it undergoes heterolytic cleavage or fission of the bond. This bond pair electron moves towards X, becoming negative, producing this carbon as carbocation. Okay, this is method number one. Method number two, by protonation to alkene. Protonation to alkene. This is an alkene. When proton is coming, then pi bond is moving towards this H plus and accepting that H plus. Suppose this carbon is accepting the hydrogen while the other carbon becoming positive charge. So this is again a carbocation. And the third type is protonation to alcohol. Protonation to alcohol. All these are important during the course of properties of alcohols or alkenes, etc. So protonation to alcohol. Let us consider one alcohol, RCH2, CH2OH. We know that this oxygen of OH group having two sets of lone pair of electrons. When a proton is coming, then this lone pair is donated to this proton. It is forming protonated alcohol. Protonated alcohol. That means OH2 plus. After that, what is happening? This OH2 plus is taking this bond pair electron and releasing as water. Releasing as water, and we are getting a carbocation. So these are the topic about the formation, how the carbocations are being formed. Next is the types of carbocation. There are mainly two types of carbocation. One is a non-classical form, where the positive charge moves from one position to the other, and the other is a classical form. Let us consider with the non-classical form. This is allyl carbocation, where this carbon having the positive charge. Now, by means of resonance, this pi bond is moving from here to here, making the first carbon positive charge, and this is becoming a double bond. So pi bond is getting delocalized, moving from this position to this position. Another example is benzyl carbocation, where the positive charge existing onto this carbon undergoing resonance with the benzene ring to form different resonating or canonical form, thus moving this positive charge from this carbon to this carbon or this carbon or this carbon of the benzene ring. So these are the non-classical form, where the positive charge getting delocalized from one position to the other. Onto the classical form, when the positive charge remains onto the same cargo. So methyl carbocation, ethyl carbocation. These are again examples of primary or 1 degree carbocation. Then this one, which is 2 degree carbocation isopropyl, or tertiary butyl. This is a 3 degree carbocation. All are under classical form. Now let us discuss the reactions involving carbocation. You have learned about Markovnikov's addition rule, that when unsymmetrical alkene to an unsymmetrical alkene, when an unsymmetrical addendum undergoes addition reaction, then the negative part of the addendum preferably comes to the carbon atom having lesser number of hydrogen. Here we will get two products. One is CH3CH Br, 2 bromopropane. Hydrogen is coming here, bromine here, and other is 1 bromopropane. Okay, you know that. Okay, this is more stable. This is major compound. This is major compound, and this is minor compound. This is according to Markovnikov's addition rule. But the question is, Markovnikov was unable to explain some special cases, because during that time there was no conception about the mechanism of the reaction. Let us consider one specific example which is very, very important for your competitive exam. I am taking this compound. What is the name of this compound? This is 3,3,1,2,3. So 3,3-dimethyl butane. 3,3-dimethyl butane. Question is, as per MCQ, 4 options are given, but I am not giving you the option. I am asking you what will be the major product in this case. What will be the major product in this case? Most of the student, about 99.99% student who doesn't acquainted with this mechanism of the reaction, they will do this bromine to come here having lesser number of hydrogen, and this hydrogen is coming here. So most of the student will give the answer that this is the major product. But unfortunately, if it is in MCQ, this is wrong, and for the wrong choice you have negative marking. So be careful about the fact. To get the correct answer, we must have to follow the mechanism of the reaction. Follow me. What is happening? I am taking HBr. Okay. Now, bromine being more electronegative is drawing this bond pair electron. Hydrogen becoming plus, but instantly pi bond is given to this hydrogen. So what we are getting either this one becoming plus, this hydrocarbon is accepting the hydrogen, or this carbon is accepting the hydrogen and this carbon becoming plus. Now, considering the stability of carbocation, this is the primary carbocation or 1 degree carbocation least stable, and this one is 2 degree carbocation more stable than primary or 1 degree carbocation. So automatically, if you do not know the mechanism, the next step bromine will come here as per Markovnikov to give the major product, bromine here, and bromine here to give the minor product. But again, the answer is not correct. Here you have to remember one important step. So after accepting the H plus to form the carbocation, if there is a chance by rearrangement, a 1 degree carbocation can rearrange to give 2 degree, or a 2 degree carbocation can rearrange to give a 3 degree, then that rearrangement reaction will take place first. Rearrangement reaction will take place first. Now, this is 2 degree. Now, interesting thing is that if one methyl group with the bond comes up onto this carbon atom, then see what is happening. What is happening? It is becoming CCH3. This carbon becoming plus. CH3 is coming over here, and this is CH3. Now check. This was 2 degree. Now this is becoming 3 degree, and this is the most stable carbocation in this case. So we are getting 1 degree and 2 degree initially, but this 2 degree to get more stability by rearrangement, shifting this methyl group, the step is called methyl shift. We will term it as methyl shift, and the process is called rearrangement. By means of methyl shift, 3 degree carbocation is being formed. Now here bromine has been released. Since H plus is going to attack, Br minus is staying here. This Br minus will now attack this one, and the final product or the major product as per the question will be see what was our guess and actually what we are getting. Those who are not acquainted with the mechanism, they will bring bromine here, hydrogen here to give the major product. This one, 2,2-dimethyl 3-bromobutane. But actually, if you know the mechanism, you will get that 100% correct answer. The answer is 2,3-dimethyl 2-bromobutane is the correct answer. 2,3-dimethyl. Sorry, first is the alphabetical order. 2-bromo, 2-bromo, then 2,3-dimethyl butane is the right answer, is the major product. So I think after seeing this mechanism, you can find out the correct option in MCQ. So that's all about this carbocation mechanism, with a very tricky one, very, very important for your competitive exam. So hopefully you have understood that in that thing, and this is our first slide. Considering your interest, go through it. Definitely we will again meet you with a new topic. Thank you very much.